Hello everyone, I'm Marlene Cramer from Edinburgh, Napier University. Today we are looking at knot parameters in different visual grading standards. So for grading there are two main ways, machine grading and visual grading. And visual grading relies on wood features as predictors for strength, stiffness and density. The features are related to the wood properties, but not necessarily directly, but both the features and the properties are related or influenced by the growth conditions and the forestry practices in a country or region. So that means that most countries have their own standards for visual grading, and that makes sense. It makes sense that there is not one European standard. But it also means that these standards all measure parameters slightly differently, and if, for example, you didn't know which standard you want to use for grading, you would need to measure quite a few features in the wood. So we will have a look at this, at only knot parameters and how different standards measure them. Here I am, a little ghosty in front of our example beam. Let's have a little closer look at the knots. Let's say this is our phase 1, and here in the middle we have our knot number 1. First we need to measure the diameter parallel to the edge. That satisfies a number of standards, but for the German, the Canadian and the US standards we also need the maximum and minimum diameters. And of course we do this for all the knots on the face and the edge. What about these little pin knots over here? They're very small, so most standards ignore all knots smaller than 5 mm, and the Nordic grading rules even ignore all knots smaller than 7 mm. That means we don't measure them, but still we have to record their presence. And what about Ares knots like this one over here? Let's turn around the piece to see how it's situated in the timber. We see it appears on the edge and the face, and some standards allow you to choose where to measure it, but some standards require that you measure it on both faces, so we will do just that. Of course we add the measurements in the same row of our table because it is the same knot. And again we measure the diameter parallel to the edge and the diameter directly at the edge, which is in this case the maximum diameter. What are we doing with knots like this, very irregular ones? Well, some standards have guidance on this, and they suggest that you draw the smallest rectangle around the knot that fully encloses it and measure the dimensions of this rectangle. So we do just that, easy enough. What can we do with knot clusters like this one though? You see that the fibers are disturbed, the knots are not individual knots, they appear as a cluster, and some standards allow to measure them collectively. So we would measure the overall diameter parallel to the edge and the overall maximum and minimum diameter. Unfortunately, some standards don't treat knot clusters collectively, so we also have to measure all the singular knots. Here we see an encased knot with the bark on it. We just measure it like a normal knot, including the bark. And what do we have here? This is not even a knot anymore. It's a full-blown hole. This is why we also record the type of the knot. In this case, we just say it's a hole. Here we have what we call a spike knot, because its length is greater than 4 times its width. Most standards actually ignore spike knots, but the Canadian standard wants us to measure the widest width. Remember, we already measured this on the other side. We already measured all of these knots on the other side. Remember? So we just add the measurements in the table for the same knot. Here we have a spike knot on the white face, and again we need to measure its widest width, but for the Nordic grading rules we also need to measure its length as parallel to the longitudinal axis of the piece. Here we have a branched knot. You can see that it has 2 branches coming from the pith of the piece, of the tree. And most standards do ignore these branched knots, but when they extend to the edge, we need to measure them as edge knots. Let's have a look. Yep, it extends to the edge a little, but that might well be smaller than 5 or 7 millimeters, so we could ignore this specific knot. So are we done now? Is this all? Unfortunately not. We need to measure a little bit more. We also need to measure the lengthwise position of the knots, but also the distance from other knots and the distance from the edge. So if we just measure the lengthwise position and the edgewise position, we could then map the knots within the beam and would be able to satisfy all the standards. And we would be able to determine, for example, the worst meter within the beam. And then we also need the length, width and thickness of the piece to determine the knot diameter as a percentage of the surface where it is located. Of course, we can't really expect that all the knots are going through the piece perfectly straight. So for the Canadian standard, we need to find the midpoint of the knot that maybe doesn't go straight through the piece. Let's look here on the downside. It was over there. On the upside, it's a bit more to the right. And the midpoint would be in the middle of this orange line that you see over here. Is that all? Unfortunately, we still have to measure a little bit. We also need to find the projected cross-sectional area. What exactly is that? Well, of course, the knots are not only existing on the surface, but you can imagine them like a cone shape running out from the pith to the surface. So if we cut through the knots, it would look something like this. And here we can just measure the surface of the knots in the cross-section. And we only do this for the worst knot area. That's the good news. So we measure all these knot surfaces, and we also determine how much of the knot surface is in the margin of the piece, which is 1/4 of the width of the piece. So we have the projected cross-sectional area and the margin knot area. So now we are nearly done. Only for the Nordic grading rules we need to note that this face of the beam is the inner face. Why is this one the inner face? Because it is closer to the pith. So this one up here would be the outer face. We need to note this so we can later use the Nordic grading standard. And that's finally it. So if we really would want to measure to fulfill all the standards, we would end up with at least 8 measurements for each knot and 6 measurements for the whole beam. So this is quite a bit of work, and within the In Future Wood project we hope to come up with some simplified grading rules for recovered timber where you maybe don't know the origin, or probably don't know the origin of the wood, and would not necessarily know which visual grading standard would be a good choice. So yeah, stay tuned, visit infuturewood.info, and thanks for watching.